In section 7.7, we're going to talk about applications using rational expressions and about proportions. In the first objective, we're going to look at problems involving motion. So we've already seen this formula before, distance is equal to rate times time. We're going to use that formula in the first example here. In the first example, a jogger that runs 4 miles per hour faster downhill than uphill. And if the jogger can run 5 miles downhill in the same time it takes him to run 3 miles uphill, we want to find the jogging rate in each direction. Okay, so to be able to work on this equation, I'm going to have to manipulate this distance equals rate times time. And the key to this is the fact that we're talking about the same time right here. When I'm talking about the same time, I'm going to be able to make two equations where the time is going to be the part that's going to link them, that they're going to be equal. So what I want to do first is rewrite this equation to solve for time. If I solve for time, I would divide both sides by r. And so time is equal to, the r's will divide out, time is equal to distance divided by rate. Okay, I'm going to be using this equation in this form to solve many of these equations. Okay, so to set this up, I have a downhill and an uphill. These are the two types of running that we're talking about here. And I know that the time downhill is equal to the time uphill. And the time is a ratio of distance to rate. So if we're talking downhill, the distance is 5 miles downhill. The rate is he runs 4 miles per hour faster downhill than uphill. Alright, so I need to know what the rate for uphill is. The distance for uphill is going to be 3 miles. I don't know the rate uphill, so we call it x. Now I know that downhill is 4 miles faster than uphill, so that's 4 plus x, or x plus 4. Okay. So just kind of talking out how I would set this problem up. Okay, so now we're ready to solve it. We're going to multiply both sides by the common denominator. The common denominator in this case is going to be x times 4 plus x, because this is a binomial. It's not the same as this monomial, so I'm going to need both of them. So we're going to multiply by x times 4 plus x on both sides. We're going to distribute this to both sides. Alright. In the left-hand side, the 4 plus x will cancel with the 4 plus x and give us 5 times x. Equals, and on the right hand side, the x will cancel with the x and give us 3 times 4 plus x. Okay, and if we distribute, we get 5x equals 12 plus 3x. Subtract the 3x. We get 2x equals 12, and so if you divide both sides by 2, you'll get x equals 6. Now back to what that meant. Remember that x equals 6. X was the variable we stuck in there for uphill. So x was, remember, the rate, distance divided by rate. The rates are in the bottom right here. So this person runs 6. The rate right here is going to be in miles per hour. Okay, they run 6 miles in an hour if they're going uphill. And they can run 10 miles per hour if they're going downhill. How did we get 10? Remember that, downhills, whatever. When we're going downhill, downhill is 4 plus the value of x. So our 10 right here comes from that. We took our 6, which is our x, and added 4. Okay, that's going to be our answer. Okay, so let's look at the next one. The next one's very similar. It's also about speed, distance, and time. So we're going to use a similar formula. The water's current is 2 miles per hour. A boat travels 6 miles downstream with the current in the same amount of time it takes to travel 4 miles upstream against the current. Again, we have that important piece, same amount of time, so we're going to need that time is equal to distance divided by rate. So I can talk about the time of each of these, and the two times are equal. Okay, So we have up and down stream. Okay, the times are going to be equal. The time is the ratio of distance to rate. So the boat can travel 6 miles downstream, so the distance downstream is 6. And the same amount of time it takes to travel 4 miles upstream. Okay. Now it tells us that the water's current is 2 miles per hour. So if I'm going downstream, whatever the boat speed is, let's give that a variable. The boat speed is x. The boat speed when going downstream is going to be x plus 2 because the water is pushing on the boat and helping it out. But if it's going upstream, it's going to be x minus 2 because the water is slowing that boat down. So upstream will have x minus 2 and downstream will have x plus 2. To solve this, we want to multiply by the LCD. In this case, we're going to need both the x plus 2 and the x minus 2. Okay. So in the first one, the x minus 2 would cancel. We would get 4 times x plus 2 equals 6 times the x plus 2 would cancel. We would get x minus 2. And let's solve. 4 times x is 4x. 4 times 2 is 8. 6 times x is 6x. 6 times 2 is 12. Subtract 4x from both sides. So 8 equals 2x minus 12. Add 12. So far I've got 20 equals 2x. So x is 10. Remember, x again was the speed of the boat by itself, and that's what our question here asked for. What is the speed of the boat in still water without the current affecting it at all? That's our x. So I know that the speed of the boat was 10 miles per hour. If I had asked instead about how fast does the boat go downstream, well, downstream it would go 10 plus 2 is 12. Or upstream, 10 minus 2 would be 8. But this particular question just asks the speed of the boat in still water without the current helping or hindering it. Okay. Objective 3 is about proportions. A ratio is a comparison, usually written as a fraction. And a proportion is a statement that two ratios are equal. If the ratio or two related quantities is constant, it says the two quantities are in proportion. Okay, so let's look at example 3. A person pays $297 for 6 months of cable. How much would they pay for 8 months of cable at the same rate? Okay, so we're assuming that we're looking at something in proportion here. So we're going to set up a proportion. We're going to have these two fractions being equal. One of them is our known quantities. We know that it's $297 for 6 months. So we have our money and our time on the top and bottom of this fraction. So we're going to have the same values in the same positions in the next fraction. How much will the person pay for 8 months? Well, 8 months is my time. I don't know the amount, so I'm going to put an x there for the variable, and we're going to solve this. Okay. To solve this equation, we need to multiply by the least common denominator, since I've got a rational expression here. Least common denominator of 6 and 8 is 24. Multiply 24 into both of these. Okay. 6 goes into 24 4 times, so I've got 297 times 4. Equals 8 goes into 24 3 times, so I've got x times 3. Let me get a calculator. Alright, the calculator is up. So 297 times 4 is 1,188 equals 3x. And if we divide both sides by 3, we get 396. Okay, so that means that for 8 months, they're going to be paying, if they're paying at the same rate, they're going to be paying $396. Okay, let's look at the next example. Okay, if I have a two fraction situation where I've got two fractions that are equal, multiplying by the common denominator is going to turn out the same way as multiplying taking the cross product. Let me look back and show you what I'm talking about in a second. Okay, so in this example right here, since the denominators had nothing in common, I needed both pieces in the LCD. So when I canceled the x minus 2 out of the LCD, I was left with the other denominator, the x plus 2. And over here, when I canceled the x plus 2, I was left with the other denominator, the x minus 2. So the result is that when I multiply by my LCD, my least common denominator, the result is 4 times x plus 2 is equal to 6 times x minus 2. So for a two fraction situation, you can see that that's our result right here. 4 times x plus 2 is equal to 6 times x minus 2, and that's what we got. So the result is the same thing as if I were just to make that cross multiplication anyway. Just go ahead and multiply across the equal sign. That's a cross product, and it's useful when I have two fractions that equal to each other. So if a over b is equal to c over d, then a times d is equal to b times c. Let me write that again with a better marker. A times d equals b times c. Okay. And we'll just use that property to simplify the way we solve proportions. Okay, so let's look at another example here. So I want to read the problem, figure out what the unknown quantity is, set up the proportion by listing the ratio on each side and making sure that the respective units are in the right places. Like I had the dollar signs were going to be on top, months were going to be on bottom in the last proportion. Drop the units, cross multiply, then solve for the x. So the weight of an object on Earth and the weight of the object on the moon are proportional. An astronaut who weighs 160 pounds on Earth weighs 26.5 pounds on the moon. What's the weight of a person on Earth who weighs 24 pounds on the moon? So the two quantities are Earth and moon, or the weight on the Earth and the weight on the moon. So when we set up our ratios, we're going to set them up like this. Well, the first one's going to have all of our information. We know that there's a guy who weighs 160 on Earth, that weighs 26.5 on the moon. And what is the weight of a person on Earth? So we don't know. Who weighs 24 pounds on the moon. So we're going to solve this by cross multiplying. Start by multiplying 160 times 24, and then set that equal to 26.5 times x. Alright, I don't have a ton of space. I need to write a little bit smaller here. But 160 times 24 is 3,840 equals 26.5x, and then just divide both sides by 26.5 to solve for x. X equals 144.9 if I round. That was pounds on Earth for that second person. Another example, the tax on a property assessed at $65,720. Find the tax on a property with assessment value of $162,500. Okay. If they're in proportion, then I would set it up as, oops, let me erase. The first value wasn't 165, it's just 65,000 over 720 equals 162.5 over, I don't know, over x, and we'll cross multiply again. So 65,000x equals 720 times 162,500. So if we multiply those together, we get 117 million divided by 65,000, we get 1,800. So it's 1,800 for the house that cost 162,500.